Okay, so we start. So good morning, everyone. And
good morning.
Hi. So at first, I would like to explain the quiz 1. Then after that, we continue. We go to chapter 2, and in the last 15 minutes that we will have the quiz. Okay, so quiz 1. Usually I upload the quiz solutions after the quiz, but this time we have one student has trouble in the file format, so that's why I didn't upload it. Okay, so this is the quiz 1. So we have 2 questions. So one, the Olivier invested $500 in a fund, and the fund credits the interest at the nominal discount rate of 5% compounded semi-annually. So calculate the balance 5 years after the investment. So the nominal rate of discount, that means the basically the 1 minus d dollar becomes $1 after a year. So that is usual, the annual rate of discount. But here, it's compounded semi-annually. So not 1 minus 0.05 becomes 1 after a year, but rather the 1 minus 0.05 over 2 becomes 1 after a half year. So that means the 1 minus the 0.05 over 2, the 2 to the power 10. Okay, so maybe, maybe one more step. So 1 minus the 0.05 over 2, entire quantity square becomes 1 after a year. So that means for 5 years, 1 minus 0.05 over 2 to the power 10. So this becomes $1. So we have, so the $500 in the fund in the beginning. So that means that we have to multiply the 500 times the 1 over this amount, because this amount becomes $1. Yeah, maybe to be exact, 500 becomes something, and this ratio, that should be the same. So 500 over this 1 minus 0.05 over 2 to the 10th power is equal to x over 1. And the answer is $644. And B, so Liam opened a savings account and deposited X dollars on January 1st, 2018, and he deposited another X on January 2020 into the same account. Then bank credits an annual effective rate, annual effective interest rate of 6%. Account balance as of the January 1st, 2022 is 1,000. Calculate X. So the situation is that he made 2 deposits, X at the beginning. So basically, this is the January 1st, 18, and he made another deposit at 2 years from this date. So January 1st, 2020. Then what's the balance here? So this X becomes X times 1.06 to the 4th power, because each year we get the 6% annual effective interest. So we have to multiply 1.06 to the 4th power. And the next X, this accumulates the 2 years of interest, because this is the year 2 to year 4. So we have 2 years. So X times 1.06 square. So the sum of these quantities, there should be 1,000. So we solve this for X, then 419. Yeah, I think that a few students get the full credits. Maybe more students get full credits in either A or B. But I think that maybe 2 or 3 students got the full score for both questions.
So I know I did wrong for A. I used M equals 0.5 because the semi-annually I thought it was going to be once every 2 years.
Uh-huh.
Actually twice per year. So it's
Yeah, this
actually
is the kind of special terminology. Yeah, so the nominal discount rate of 5% compounded semi-annually actually is the means that the 2.5% discount rate for half a year. Yeah, and both questions come from the homework questions. That you can see that the homework question for I think the 1B2H, question 2 and question 9 or something. So the idea comes from the quiz question, the homework questions, but the sentences and the questions themselves are unique. So note that this exam, I think that one of the most important thing is to translate sentences into equations. So every question is different, as you can see the exercise questions in the textbook.
so once we go back to in person next week, are the quizzes still going to be at the end of class, or are they going to be at the?
That's a good question. So usually I have a quiz in the beginning of the class.
Mhm.
So just make sure that you will come to class at 10 a.m. So then after the quiz, then we will start the lecture.
I'm looking forward
next
to seeing
Monday,
you in
right?
State Hall next week.
Yes, yeah. So sometimes if it snows heavily, sometimes I make a quiz at the end of the lecture, but usually I have a quiz at the beginning of the lecture. Okay, so do you have any other questions? Okay, so we start chapter 2 today, and the slides are available on the website. So slides only lists the the typed sentences, and the handwritten parts are not available online. So if you would like to, you can print out and you can write on that papers. Okay, so we have already used this kind of graph in chapter 1, but we just have more rigorous way to use this so-called time diagram in chapter 2. And also that we discussed how to solve for unknown interest rate, or how to solve the unknown time for the question. So suppose all other conditions are given, then we calculate the unknown interest rate, or all other conditions are given, then we calculate the time period, for example, for the money that will be in the account. Okay, so time diagram first. Okay, so here the I, if we say I, the I is the annual effective interest rate. Often this interest is omitted in the exam questions. So if we say the annual effective rate, that means annual effective interest rate. If discount rate, always it said the annual effective discount rate. And the idea of the time diagram is to write the cash inflow on one side of the line and cash outflow on the other side. So inflow and outflow, they should have the same value. So that is the time diagram. So yeah, and to equate the value for inflow and outflow, that we have to use the same time point, because $1 today and $1 a year later have different value. Usually the $1 now worth more because it can accumulate the interest for 1 year. Okay, so just several the most basic examples. So simplest time diagram consists of 2 points. Maybe we need a little more space. Okay. Okay, so for example, the $1 here, then if the interest rate is I, 1 becomes 1 plus I here. So this is one time diagram. So for example, you deposit money into the bank account. You deposit $1 into the bank account. So this is $1. And if and you withdraw money a year later, so 1 plus I dollar. Then after that, the balance is 0. So, or we can say that this $1, the value of this $1 and the value of this 1 plus I dollar is the same. If we use the same time point, this 1 becomes 1 plus I, or you can say this 1 plus I dollar is worth $1 at time 0. This is here. So so this time diagram is correct. And which is inflow, which is outflow, that is a subjective problem. So if we think about the bank, the balance for the bank, then basically $1, the first $1 is cash inflow, and the 1 plus I dollar is cash outflow for the bank. But for the individual who deposits money, $1 is cash outflow and 1 plus I is cash inflow. So it really the subjective, which is inflow and which is outflow. And yeah, maybe we can review the some notations with this time diagram. So at first, we often use V. V is 1 over 1 plus I. So if we have the 0 and 1 here, and if we have V dollar here, V is equal to 1 over 1 plus I. Or we can also say this is 1 minus D. So this is worth $1 after a year. So maybe I have to put $sign here to be exact. Yeah, so this is also a correct time diagram. Or we consider the half year of interest. If annual effective rate is I, then after a half year, $1 becomes 1 plus I to the power 1/2. So this is also a correct diagram, time diagram. Or if we have, sometimes we have different scale, such as month. So this 0 means the time 0, and 1 means 1 month, 1 month later. Then the $1 becomes 1 plus I to the power 1/12. So all others are for year, and the last one is for month. So this is how the time diagram is constructed. Do you have any questions? Okay, so we now have more complicated example. Sometimes the simple examples are more difficult to understand. Yeah, so example 2, suppose that the interest rate, annual effective interest rate is I. So in chapter 2 and 3, mostly the interest is constant. So sometimes it's changing over time, but in many cases it's constant. So deposit of 2x was made today, and 3x will be made a year later. And payment of $500 a year for 3 years will be made starting 2 years from now. Then the balance will be 0. So determine x. So we make the deposit of 2x, after a year, 3x. Then after that, we withdraw $500 3 times once a year. Then the balance becomes 0. Then we would like to calculate x. Okay, so this is at least more complicated question than examples in chapter 1. So how many years we have? We have at first time 0 and time 1 at time 0, we have 2x. So some demonstration purpose, we just put 3x here. You can put 2x here and 3x here, but we just put in this way. Then after a year, we withdraw $500. Then after a year, again 500, and after a year 500. Sorry, this may be too long. I think it does not really work. Okay, so the time diagram should be, maybe I also put 500 here, 500 here. And interest rate is 5%. And this is for a year. Okay, so the important thing to solve this kind of question is to evaluate all cash flow at the same time point. So we can either use time 0 or 4, or if you want 1 or 2 or 3, also you can use those. And anyway, so this 3x becomes, oh, before that, maybe I would like you to guess the answer. 5% interest, what is x? Finally, you will get $1,500 in total. Anyone?
You want me to find out what is x? Or
Yeah, x, yeah.
let me see. I'm gonna say, hold on. $400.
$400, x. Okay. Any others? Maybe 4 people can answer.
290.
290. Others?
300.
300.
320.
320. Okay. So my guess. Okay. So the simplest way to state this situation is that we deposit $5x, and after that we will get $1,500, right? So this becomes this. So okay, so maybe x is equal to 300 is the simplest guess, but it will accumulate some interest. So x should be less than 300. So I think the Donovan is probably closest. Possibly maybe 300 is closer, but maybe my guess is, okay, so my guess is what? Okay, so the money is in the account for several years, right? So maybe, I don't know. So deposit is made, maybe my guess is deposit is made at about year 0.5, or we would say maybe 0.6 or something. And we will get money on average at time 3. So I would say that the money is in the account for about 2.4 years. So it accumulates interest of maybe 12%. 1 year, 5%. So 2.5 years, 2.4 years, 12%. So probably X is maybe 11% less than $1,500. So that means maybe this is 1350 or maybe 13, I don't know. But the X maybe 270 or something. So that is my guess. So maybe all answers are probably larger than the truth. But maybe 290 is the best guess among these 4. Okay. So if you got the closest answer, you will get basically 2 points on your weekly quiz score. Okay, so we'll calculate it. So 3x, this is worth 3x times v, because we go back 1 year. V becomes 1. So 500 is worth 500 times the v square here. And 500, this 500, second payment of 500 is worth 500 times v cube. And the last one, this is worth 500 times the v to the 4th power. Okay. So what is v? So v is, okay, so v is 1 over 1.05. So it's a little more than 0.95. So this is actually 0.9524. Okay, and yeah, so now we can calculate it because we can see that the the cash inflow and cash outflow have the same value. So this one and this one have the same value. So 2x plus 3x times v is equal to 500 times v square, v cube, and v to the fourth power. So that means x is equal to 500 times v square, v cube plus v to the fourth power divided by 2 plus 3b. So plug in numbers. Then 266.99. So 290 is the closest answer. Do you have any questions? So one quiz is similar to this. So daily quizzes, it's very similar to examples in lecture. Homework questions, a little more difficult. And the weekly quiz, probably slightly easier than textbook questions. Okay, so next example, example 3. Suppose the annual effective interest is 10%. And the quarterly deposits of $100 each will be made for 3 years. So how many deposits? Quarterly deposits for 3 years. So 12 deposits. The first deposit will be the 3 months from now. How much is the accumulated value? So the idea to solve this question or a strategy for this question is to use the time unit equal to 3 months, 1 quarter. So everything should be written as written with this time unit, 1 quarter. Yeah, so at first we have to identify what is what the quarterly effective interest rate is. So we write this as J. So we have I is equal to 10. So this is annual effective rate. So we have to transform this into quarterly value. So that means that we can see that the 1 plus j to the fourth power is equal to 1 plus I. Right? So that means the j is equal to, sorry, the I is 10%. So I would say that this is 0.1. So we take the 1/4 power on both sides. Then after that, we move 1. So j is equal to the 1.1 to the 1/4 power minus 1. So this becomes 0.02411 or 2.4%. So that becomes 10% effective, annual effective rate. And now also we define V. We define V as 1 over 1 plus j, not I. So then this becomes 1 over the 1.02411. So this becomes 0.97645. Okay, so this is the V. So now we can use this and this for quarterly diagram. Yeah, if we use annual diagram, then it's much harder to get the answer that we have to use t is equal to 1/4, 1/2, the 3 quarters, and so on. So if we use quarter as the time unit, that we can say just we have 12 payments. So we have the $100 deposit each. So 100, 100, 100, and so on. Okay. So now that we want to calculate accumulated value. So accumulated value is here at 12. Yeah, so there are several ways to calculate this. So we have calculated the present value first. Then after that, accumulated value. So we have calculated present value. So maybe we can calculate present value, then we translate it into the accumulated value. So just evaluate all cash flow at time 0. Then after that, we can calculate the AV. What's your guess on accumulated value?
1350.
Sorry?
1350.
1350.
13.
Yeah.
135.
13, sorry. Yep. Yeah, so it's right that we have deposit of $1,200. So accumulated value should be larger, right? So this is one reasonable answer. How about others?
$1,363.
Okay, so your answer should be there were $10, at least $10 different from this. Okay, so you can say 1,340 or 70, 1,400. Okay, so you can, and any others?
1,000.
Sorry.
1,380.
Okay, another one?
1,400.
1,400. Okay, so at first, my guess. So 10% interest, right? And the annual. And we have 12 deposits over 3 years. So that means the 3 years. So those 12 deposits, on average, are in the account for 1.5 years. So I would say that the probably 15% interest is added. So we have the $1,200 and we have the 15% interest is added. So 180. So 1,380 is my guess. But anyway, so this is not accurate. So I don't know, maybe these are closer. And I would guess that maybe this has the highest possibility to be closest. Okay, so now that we can calculate it. And present value is, maybe I should use this one. So present value is the same as the current value of these deposits. And for example, this deposit 100 is worth 100V, and the next one is worth 100 times V square, and so on. So that means the PV is equal to 100V plus 100V square plus up to 100 times B to the power 12. So yeah, you can add up these 12 numbers, but we have a shortcut if you use the summation of geometric sequence. So 100V times 1 plus V square up to B to the 11th power. So that is equal to 100 times the V times. You can see that this is the 1 minus the V12 over 1 minus V. V is less than 1. So the 1 minus V12, this is easier to go rather than V12 minus 1 over V minus 1. Okay, so this becomes $1,031.30. Okay, then we calculated PV. So now we want to calculate AV. So AV accumulates the 12 quarters of interest. So we have to multiply V to the, maybe I would say that the PV is the V to the 12th power times AV, or we can say AV is PV times V to the negative 12th power. So that means the AV is equal to the V negative 12 times PV. So this becomes, okay, so 0.97645 12th power times the 1031.30. Okay. Then 1300, the 72.64. So yeah, 1360 is also close, but still this one is closer. Who said 1380?
That was me, Luke.
You? 1380?
Yes.
Okay. Okay, so this is the answer. Maybe next time I will ask the other students to answer. Okay, so if you yeah, so maybe the Ken and the Donovan got 2 points already.
No, that
So
was, sorry, that was Luke on the second one.
Oh, sorry?
Luke on the
Luke is the
1380.
1380?
Yes.
Oh, okay, sorry. Luke. Okay. Okay, so now that we want to use the calculator to do this. Have you brought the this BA2 Plus or BA2 Plus Professional? Yeah, you can just oh, and you can turn on the video. Okay, so yeah, okay, that's great. Okay, yeah. Anna also has one, and any others? How many of you have one? I don't know. Oh, you already put some seals. Oh, okay, great, great. And yeah, okay. So I would explain how to use it. So I want to calculate this, you know, the accumulated value. So at first, you can of course turn on the one, and you can put the second. Second is here. I don't know if you can see it or not, but the second is just the second row and the first column. So 2 ND, so gray bottom. So second, then the clear TVM. The clear TVM is the third row, last column, the most right. So actually, the button itself says FV, but over this, we have the gray letter, the CLR TVM. Okay, so we put the second. Okay, so second button and clear TVM. Okay, clear TVM is also we can see FV. Okay. Then this clears memory. Okay, so this clears. If you calculate something before, then it clears memory. Then after that, okay, we have the 12 periods. So 12 payments, I mean 12 deposits. So we put the just 1, 2. Then the push button N. N is the third row, the first column, N. Okay. Then after that, the 2.411. So this is interest rate. So I over Y. So this is all usually used for annual interest rate, but now that we are using, you know, the quarter as a time unit. So just we ignore this Y and the interest rate be 2.411. Then after that, the $100 deposit each quarter. So 100. Then we make it negative. So we put the plus minus sign. So plus minus is just at the bottom, the second one from the right, and 100 the plus minus. So this means negative 100. Okay. Then compute. Compute is the top left. Then finally we can put the PV. Then we get this 1031.30. I can try that. Okay, so 12. Did you get the same answer? 12n 2.411 I over y 100 minus and the 100 minus payment. So sorry. I'm sorry about that. So we have to put the payment. So this is payment. Then compute present value. 1031.32. Actually, not 30, 32. 33 maybe. 326. Okay, so maybe this should be 32. Okay, 6. Yep. Did you get the same answer? Anyone? Yeah, I cannot really. Okay, great. Yeah. Yeah, I think that in default mode, probably we have 2 digits after decimal point. Yeah, and maybe another calculation. So if we want to calculate the accumulated value at once, then you can do almost the same thing. Maybe you have to start over again. So second clear TBM 12n 2.411 I over y negative 100 payment and compute FV. Then you get this one. The future value is denoted as the FV, accumulated value. So I think that you have to start over. And the 12n 2.411 I, then 100 minus and the payment, then compute FV. Then you get the 1372.64 you can get. Did you get the answer? Oh, you got it? Okay, great. Yeah, so then you can do this way. So how this function works? So basically this function have 5 unknown numbers. So n I over y, payment amount, and the PV and FV. So we can calculate the one of these if the other 4 are given. So maybe or one of these if the other 4 are given. But one exception, if PV or FV is not given, it assumed 0. It is assumed 0. So maybe to be exact, the equation this function solves is that okay, so we have basically we have 0 to n. Interest rate is I over y. Actually, I over y is given as percent. Okay, so percent. Then, sorry, the 1 to n. So 1, 2, 3, ... up to n. Okay. Then payment. Payment amount here. Payment, n times. And the future value here. And present value here. So now we have n, I, and the payment and the future value and the present value. So we have 5 quantities, right? Payment and N. Okay. And the point is that the all cash flow is one side of the timeline. So in our case, usually that we want to have payment on the other side of the line. So that's why that we have to put this as negative 100. So this is how the function works. And the future value and the present value. So we have another option. So we have maybe additional lump sum payment at time N. Then we can put it as a future value. Then we can still calculate the present value. So for example, if we have 100 here, maybe negative 100 here, negative 100 here, then maybe at last, then we may put negative 500. Maybe last $500 deposits here. Then the PV is probably the larger by maybe $400 or something like that. So we can calculate a little more complicated the present value, for example. Yeah, so I would say that the payment and the PV and the FV are all cash inflow. So PMT, payment, should be negative to get positive PV, to be negative if it is cash outflow. Okay, and the total cash flow should be 0. So this is the way the TVM, time value money function, works. And one similar question to this in quiz 124.3. Any questions for this question or how to use BA2 plus? And for this use, actually just the calculation by hand works. Later, I will have an example which cannot be solved by hand. Okay, so if you don't have a question, then we go to the next section, 2B. Okay, so 2B, the unknown interest rate. So example. So suppose that you deposit $100 at time 0. And you withdraw $30 at time 1, I mean 1 year after, and $40 2 years later, and the $50 3 years later, I mean 3 years from now. So then the fund is depleted, so the balance becomes 0. And what is I? So here I is unknown, but the all cash flow are given. So can you guess the I? Anyone who didn't answer before? Aaron?
I would guess like 7%.
7%, okay. And Anna?
I'll say 5%.
6. Another one? Oh, sorry.
5%.
5%. 7%, and the other? Maybe.
8%.
Sorry, 8.
8, yeah.
Okay. Okay, so $100 finally becomes the total of $120, right? So my guess is 100 becomes 120, so 20% interest, and the $100 is in the account on average, roughly about 2 years, right? So some money is withdrawn after a year, and some money is in the account for 3 years, but on average, maybe 2 years. So my simple guess is 10%. Okay, 2 year 10%. So 10%. Okay, so let's go. What's the amount? So basically, what question we have to solve? Okay, so we have to evaluate money at some specific time point. Usually 0 or 3 is the best. And $30, okay, so we use the time 0. Then $30 is worth 30V. And $40 is worth 40V square. And 50 is worth the 50V cube. Okay, so I don't have enough space, but the basically we can solve this. So 100 is equal to 30V plus 40V square plus 50V cube. We can solve for this. And we cannot solve this because this is the 3-degree polynomial. So if we don't use the sum, the Ferrari's, the the solution to this 3-degree polynomial, we cannot do that. But if you use computer, we can identify it, and the V is equal to 0.91828. So that means, okay, so remember that the V is equal to 1 over 1 plus I. So that means the 1 plus I, maybe I would say that the V plus VI is equal to 1. So I is equal to 1 minus V over V. So I is equal to 1 minus V over V, and we get what? 8.9% approximately. So actually 10% is not really close, but still, yeah, maybe 8%. And this maybe beats me. So who said 8%?
Garrett Coletti.
Okay, Garrett Coletti.
There's 2 of us, so
yeah. Okay. So 8.9% is the answer. Okay. Yeah.
I'm sorry, Professor. How did you get the V for the? How did you get 0.91 for the V?
Sorry, how to get this this number?
Yeah, I'm sorry, I missed it.
Sorry, I didn't really explain. So if we use some computer to solve this, cubic equation, then it will give 0.91828. So I didn't explain that. So
Okay,
if you use computer to numerically solve it, yeah. Okay,
thank you.
And but from now on, I will explain how to calculate it with this the BA2 plus. Okay. So we use the cash flow function. So we put, at first we use the CF button. CF is the 2, so the second row, second column. So cash flow. And we have to clear memory again. So second. Then after that, the CEC, clear. So second CEC. CEC is at the bottom on the left-hand side. I mean the most left. Then after that, we put 100. 100 is inflow, and actually just 100. Okay, then after that, we put the negative sign. Oh, sorry, 100 negative plus minus sign. So overall, so this means negative 100. Okay, then enter. ENT. ENT is where? Yeah, so the top second one from the left. So top row and the second column. Enter. To be exact, enter. ENT. ER. Enter. Okay. So then enter. Okay. Then we go down arrow. Down arrow is just the first row, the fourth one from the left. Did you put it? Then you should see this C01. C01 in the screen. C01 and 0. Okay, C01. And so we put the CF0 as this, the cash flow at time 0. Then now the C01, so cash flow at time 1. So C01, you see C01. So then we enter 30. So the idea is the 30 is the other side of the time diagram. So 100 was negative, so 30 should be positive. So just 30, then enter. Then, okay, 30, enter. Okay, then down arrow. Then actually you will see the F01, F01. So this is the frequency. So the how many $30 payment will be made, and only one payment. So, and the default value is 1. So you don't really have to put anything. So you can go down again. Then you will get the C02. You can see C02, then you put 40. Then again, enter. Okay, so I only write the ENT here, the same enter. Then go down arrow, and again go down. So you will see the F02, but we don't use this. And the C03, C03 is 50, and enter. And I think this is the last one, so we don't really have to go down. So just enter. Now we put all cash flow. So C02 is 40, enter, go down, C03, 50, enter. Okay, so now everything has been input. So then we push the IRR button. So this means the internal rate of return. IRR is where? So this is the second row, the fourth column. Okay, so IRR, then the compute CPT. Then you should get 8.896%. Did you get 8.89 or 8.90? It depends on how many digits you are using. About 8.9, did you get? Yeah, thank you. Yeah. Okay, so this is the way to calculate it. 8.896%. Yeah, so this is the often useful function. So usually in the investment, okay, you have initial investment of $100, and it has the it makes cash flow of $30 after a year, $40 after 2 years, and $50 after 3 years. And what's the return of investment? That is 8.9% here. Yeah, so this is how to calculate the I, and that cannot be done by usual calculator. So basically BA2 plus solves the cubic equation, or you can even solve the more complicated cash flow, such as 30, 30, 40, 40, 50, 50, 30, 60, 100, or the longer time diagram that you can describe in this calculator, then calculate the internal rate of return or the unknown interest rate. You will have one quiz question here, 123.3. So 4, sorry, 123.4. Yep. Okay, so okay. The last one, I don't know if we have enough time, the 5 minutes, but I will try. So unknown time. So this time the time is unknown. So think about we have two cash flow. Maybe two people have the same amount at time 0, the X dollars. And for the first person, he or she, the withdraw $10 at time 6, and $30 time 9, and $40 time 12. And the interest rate is both 5%. So the V is equal to 1 over 1.05, so 0.9524 again. Okay, so both interest rate of 5%. And unit is Y. And another person, he has the same amount X, but he withdraw money at time T as a lump sum, so T, and we have amount $80. And both the time diagram, the depleted funds. So after the last withdrawal, the balance becomes 0. And what is T? So T cannot be less than 6 or cannot be more than 12, right? If we wait after the more than 12 years, of course, it accumulates more interest. Less than 6 years, of course, it accumulates less interest. So the amount cannot be the same as this. 10 plus 30 plus 40 is 80. So it cannot be the same. So T is between 6 and 12, right? And we want to solve what is the T. Okay. Maybe the guess is maybe between around here, so 10 years. Okay, so how to solve it? And actually, this is mathematically not difficult because the $10 is worth 10 times the V to the 6, and 30 is the 30 times the V to the 9, and the 40 is worth the 40 times V to the 12. And $80 is worth 80 times the V to the power T. Right? So that means, okay, so compare, or I would say evaluate cash flow. Maybe evaluate is more. Cash flow at T is equal to 0, okay, times 0. Then we can say that the 80 times V to the 9th, V to the T's power is equal to 10 times V to the 6th power plus 30 times V to the 9th power plus 40 times the V to the 12th power. Okay, so this means that if we take logarithm, then, okay, so maybe we divide by 80, then take logarithm. Then T times log of V is equal to log of the other amount. So 10 plus 10 times V6, 30 times V9, 40 times the V12 over 80. Sorry, 80. Yep. Then what? The T is equal to log of V in the denominator and the log of the 10, 6, 39 and 60, sorry, 40 V12, right? V12 minus log of 80. So this becomes actually the 10.02 year. So about 10 years. That sounds reasonable. So we have a similar quiz to this. Do you have any questions? I could not explain the last slide, but basically you can solve all quizzes today with this materials. Okay, so now that we will have a weekly quiz, so it will be available in 1 minute. So you can download it and answer it and upload it. And it's due 11:25 today. If you are 1 or 2 minutes late, that's fine. So 11:25 a.m. is the deadline. You can scan it, or you can take a picture of it by cam scanner. Okay, so have a nice day, and good luck on your quiz. I will be here until 11:25.